Right. Hello. Um, Welcome back to the stream. And today I want to continue where we left off last time. Right. So if we take a look at what we did last time, we can simply um, run our compiler and we will have an AST built from the program that we have written on the right side. So we get 35 plus 17 times 2. Right. Now, today I want to convert this AST into an intermediate representation and then convert the intermediate representation into assembly so that we can have um, our first compiled program, right? But before we go for intermediate representation, I wanted to get done with some to-dos, right? So first, neatly print errors. I guess what I want to do actually is just uh, derive debug over here, right? And then we can go to main rs, and here we can just uh, eprint line, and here we need to get the error in, right? So it's the error, right? Of course. So exit 1. So let's try to compile it again. Right, and now if we mess something up, like say we give 2 stars, right? And we try to compile it now, it will say add an error for this, right? Of course. Oops. So it's in parser 961. Right, so we need to get another error in here, and that's expected tokens, and we will say expected is APEC of token kind, and found is a token kind, and we can go to parser, and here we'll just say error, front end error, expected tokens. So we expected back of token kind num literal, but found we can just do token dot kind, right? So now let's try to compile it. Right, so we get the error saying expected token kinds. So we expected a number literal, but we found a star, right? So we're getting errors correctly, and I guess if I do 2 space, let's see what kind of error we get. Right, so we don't get an error because it just stops here and it does not pass the second 2. Right, so we only get 1 2 here. That's all right. Now that we're done with that, I wanted to go with the IR. Let me just commit this stuff before. Added debug printing errors. Right, now we can go with the IR. Right, so we can do backend, and inside that let's make the ir.rs. Let's also make the mod.rs. Oops, what's this? Let's also make mod.rs, and then we can go to, let me just close all. Right, and oops, I don't know what I'm doing. And we'll open main. Right, and then let's just mod backend, and let's go to backend. Let's close this one. Right, so we'll just leave this here for reference, and we'll just say mod IR, and I guess I want it to be public. Right, so in the IR, essentially this expression in the AST has to be converted into an intermediate representation. So for this, I think I'm gonna first say that we need two structures to represent the intermediate temporaries and the intermediate literals, right? So let's just make that. So pub struct IR temporary, and we just have an ID is the usize. So this will just be a temporary, and then we'll make a pub enum IR literal, and currently we only have a number literal, right? Sure. Now we can make the actual IR instruction. So IR instruction, and we're gonna have 5 instructions to start with, right? So the first instruction is a set instruction, then we have an add instruction, a subtract instruction, a multiply instruction, and a divide instruction, right? So the set instruction will have a destination, which is essentially the IR temporary that we want to set it to, and the source is the IR literal that we want to set into the temporary. The add similarly has a destination, which is an IR temporary, right? So the addition result will go into this temporary, and then we have the first source, which is an IR temporary. So that's the first temporary, and then we do plus src2, which is another IR temporary, right? And we will just yank it till this thing. Yank, find this thing. Okay, I guess it yanked it. And we can do paste, undo, paste, and was I doing before? I don't know. And so this should give us this thing. I'm actually gonna undo it, and I'm gonna say rust fmt skip. So I don't want it to format this thing because it looks better this way, right? So we have these instructions that we're going to eventually convert it into, right? And let's just make this public as well, because why not? So actually let's not, and let's just impl ir temporary, and we'll say pubfun new id is usize, and we return a self and self id, and pubfun id on self, and it returns a usize, and it returns self.id. Alright, so now we have that. Let's just quickly define the function that we're going to call. So it's going to be a pub function generate ir, right? And it should take in the AST. So this will be an AST expression for now, and we will give back a vec of ir instructions. So this is what we're going to generate, right? And here what we will say is just to do for now. So we need to generate the IR, right? So for that, let's quickly make another module called irgen.rs. And essentially here we want to generate the IR. So let's quickly make a public function, call it AST expression to IR, AST expression to IR, right? And we take in an expression that's an AST expression, and we're going to return a vec of IR instructions. And let's go here, let's mod irgen. Right, so now obviously we have some errors. Let's get this, and now let's go ahead and make this thing, right? So essentially, what is the AST expression, right? AST expression is either a number literal or a binary, right? So let's match, before we match, let's just make the IR. So let mute IR is a vec new, and we return the IR, and let's say match expression, right? So let's quickly fill match arms, and we'll say if it is a number literal, I'm just going to use AST expression star, because I kind of don't want to write these again. This is easier, right? So we have a number literal, which is a value. So so the number literal will essentially convert into a set instruction. So let's say that instruction is IR instruction set, and the destination we need to get a temporary, and the source is the IR literal. So IR literal number literal with the value. And we need a destination. So for that we're going to create a new structure that's private here. So struct, let's say temporary iota, and we'll say it has counter, which is a usize, right? So we can impl temporary iota, not pub, just fun new, and it returns self, and we'll just return self with 0, and fin next on mutable self. It's going to return a usize. Let value is self.counter plus 1 and value. Right, so we can go ahead and make our iota is temporary iota new, and we can just say actually, you know what I'm gonna do? I'm gonna rename this to just iota, because that makes more sense. And here what I'm gonna do is insert IR temporary new with iota dot next, right? And this will essentially be the instruction, and we can just do ir dot push instruction. Then if it's a binary, right, in the binary we will say match op dot kind, right? So if it's, let's just get it. Oops. And I don't really like this, whatever. So a number literal should not ever exist, right? So here what I'm gonna do, we're gonna say unreachable. Otherwise, if it's a plus, then we need to make an add instruction and so on. So let instruction be IR instruction add, with the destination being an IR temporary new iota dot next, and then source 1 is going to be, so now here we need to essentially do something. what I'm going to do is I'm going to say IR is a mutable reference to a vec of IR instructions, right? And we're just going to return a U size, or rather we're going to return an IR temporary, right? So here we can just delete this, and we can delete this right here. It's gonna mess up a bit, but yeah. Okay, so let's just say let temporary is, and let's temporary, and let's say temporary. So we're gonna return the temporary. Now obviously it's gonna give us an error, but here we can just derive debug, comma, clone copy. It's completely fine to do that. And I guess over here also we'll just, since we're deriving stuff, let's derive debug and clone, and let's derive debug clone. Let's go to IRGen. So this does this, right? So I'm gonna say cut this and just say let temporary is this thing. Then we say destination is temporary. Then source 1 should be AST expression to IR, and the expression is LHS, and the IR is just IR, and the source 2 is also AST expression to IR, and we give RHS and IR as IR, and then we simply just do IR dot push instruction and temporary. So this does this. But now, so here we can just unwrap it. Oh, sorry, dereference it, and we have got it. Right. So now I'm just gonna copy this and paste, and this is just gonna be subtract. Same here, I'm just gonna paste. Oops. Copy this, paste it. It's gonna be multiply, and my god, copy this, paste it, and this is gonna be divide. And here I'm actually gonna keep it anything, right? Anything else is just unreachable, should not be reachable. And this thing should generate our AST expression for us, right? So now what I'm gonna do actually is impl, not display, impl debug, fmt debug for IR temporary, right? And here we can say write into the formatter, and we want to say percent and self.id, and that should be fine. Now what's the error? First implementation here, second implementation here. Right, now IR literal, I'm also gonna get rid of it, and we're gonna impl debug for IR literal, and implement missing members, and we'll simply do write into the formatter, just oops, it's not like that, but okay, we'll match on self, fill match arms, I'm gonna change it to value, and write into the formatter this thing and value, that should be fine. And here I'm just gonna impl debug, just gonna implement it here for IR instruction, implement missing members, and let's match on self, fill match arms, and here what we can do is write, and what we want to write is destination is equal to source, right? This thing is also going to be right. Oops, my bad. This is also into the formatter, and it's add, so it's going to be destination is equal to source 1 plus source 2. And I guess I'm just going to copy this. My god, why do I not like this? Okay. And here we can just replace this with minus, we can replace this with multiply, and we can replace this with divide. Right, so we can print stuff now neatly. And now let's go to mod. Let's just say we have like mute IR is a vec new. Then we're gonna do AST expression to IR. The expression is AST, and the IR is a mutable reference to itself. Right? And it does return us a temporary, but we don't really care, and we can simply return the IR, and it should be good. So now let's go to main RS, and we will say let IR is, we don't need to match, we can just do backend generate IR from the AST, and here what we will do is essentially for instruction, but rather let's just quickly write it. So ir dot iter dot for each instruction I, we just want to do print line I, it looks good, and we'll just do print line, just some separation so that we have good separation in there. Let's try to run it. Right, so now we can see here it's completely wrong. What the hell? Oh, of course it's wrong. Of course it's wrong. My bad. So this does not need an iota. Right, iota is not made in here. It's instead passed in an iota. Mutable reference to an iota. Right, and what we will do is let's make this public, I guess, for now. And let's go to irgen mod. What's the error here? Expression. Here we need iota, and we need iota, and we need iota, and we need iota, and we need iota. So this should fix the error in here, and here we just need to make an iota. Oops. Let mutable iota is iota new. And now let's try to do it. So now we can see that our expression was converted into an intermediate representation, right? So you can see that 1 is 35, 3 is 17, and 4 is 2. So we have got then we do 3 times 4, so that's 17 times 2 is in 2, and then we do 0 is 1 plus 2, so 1 is 35 and 2 is the multiplication, and we get the result in 0. So we can see that we are done with IR generation, right? What is the error? Whatever. So I'm gonna push this to GitHub, git add done expression IR generation. And this was for generating the IR for now, right? Um, so I guess we will leave code generation for another video, another stream, because it is actually a bit complicated, I guess. It's not as easy. So, yeah, I guess I'll see you in the next stream.